Well, that's the last screw for finishing up the boom and all of its bronze hardware. Now, in addition to making the boom in this episode, I also cast all of the bronze fittings for it. And I did that with a special method. So let's check out the plans. On sheet 6 that shows the spars and hardware, you can see the drawing of the boom. Now, the boom is made out of spruce, and in addition to the wooden spar, there are several pieces of hardware that needs to be attached. The first being are the main sheet block, which goes onto a main sheet boom bale, and there are 2 of them right here. Now, that is all drawn right here on the plans so that we can recreate this in bronze. Now, to show you why those are located there, let's look at the sail plan. So on the sail plan, we can see the location of the boom here. So what happens is the main sheet comes up and off of a sheave and then down to the traveler rod, and then it comes up to a sheave and over to another sheave and then down to the centerboard trunk here, which is located somewhere about there. And at this location is where we attach the cam cleat from the last episode. So these are where those 2 boom bales need to go. Now back on sheet 6, so the other parts on the plans here are these boom plates and a little fitting that is right here. Now those are all listed right here. And the first thing is the mast plate. Now this attaches to the mast in this orientation here. So this is a side view of it. And then there's a small little universal piece that fits in here with a pin that goes through it. And there's 2 views of this. There's only one that is required. And then attached to this are the boom plates. And there are 2 of those on each side of the boom. And this shows that boom plate right there. Now the critical thing here is the center line of this union piece here is what is measured off of for the length of the boom spar. So what we're going to do first is to cast all of these parts before I make the boom. So my friend Steve is very proficient in 3D modeling, and so he agreed to model all of these parts in a 3D software called SketchUp. So that's what he did first, and what we're going to do is to essentially do a process called lost PLA. Now PLA is the filament that is used for 3D printing. Now what PLA stands for is this word right here, and I'm not even going to try to pronounce it. So anyway, let's take a look at how I did that. So on the computer screen here, we can see a couple of parts that are in an STL file, which is what's needed for them to be printed. So the first one here is the main sheet boom bale. And if you remember, we need 2 of these. And one of the things that Steve did is he designed right into the part some in the back here so that this is the gate for the metal. So that was actually then printed right into the part. And the other part we need here is, this is the mast bale, and you can see it, and it's got the same thing printed on the back of it so that it too is the gate for the metal to go in there. Now the other thing we need are 2 of the boom plates, which is right here, 1 for each side. So we'll print 2 of those. And then the final thing that we need is this little universal piece. So let's see how these all printed. The first thing I printed were the main sheet boom bales. And once those got printed, and this is what it looked like when it was all finished, the next thing I printed was the mast bale and the little universal joint. We printed those together because that universal joint was really such a small part. Now I had set the printer at 20% infill, and you can see here with those two little columns coming up that the piece essentially was almost hollow. Now the benefit of that is that there was a lot less plastic that would have to burn out when we invested them. And here's what they looked like once they were all finished printed. The next thing I printed were those mast plates. I then sprued and gated those parts on a wax tree, and it was then ready to be put into the ceramic shell investment. Now I followed the very same procedure that I did in the last video, and if you're interested in seeing the entire process of ceramic shell, you can see that in the upper right hand corner. There's a link there, you can watch that video. So I didn't follow any different procedure in casting the PLA as I would in casting lost wax. Now wax melts out at around 200 degrees Fahrenheit, and the PLA melts at around 340 degrees Fahrenheit. Now both of those are very close in melting temperature, and the burnout kiln is 1000 degrees Fahrenheit. So there's absolutely no worry about both of those melting out, and at the 1000 degree Fahrenheit, any ash or soot that is left in there gets vaporized. So I've got all 6 of those pieces cast, and now I need to clean them up. Well, I've already cleaned up one of the main sheet bales here, and you can see on this casting where it still has the gates on there, and what I need to do is to grind it out so it's nice and smooth so that it'll fit on that round boom. So I'll need to do the same thing here with the mast bale as well, as to grind all of those out. So to get started with this, I have a series of grinders that I work through. So I have 3 grinders here. The first one, I have a cutoff disc on it, and you can see it's quite thin. It's actually about a 1/16 of an inch thick. Now, this is really great for cutting things off, but you do not want to grind with this. So I have on this grinder, I have a grinding disc, which is much thicker, and that can grind out the majority of those gates that are in there. And once I get those done, I then go to the last grinder here, and it has a flap wheel on it. And this actually happens to be an 80 grit flap wheel. So once that's all done, I'll then drill the holes in those pieces where they need to be. And once that's finished, I'll then use sandpaper and hand files to finish it off, and eventually then put it on the buffing wheel. So I'll get started doing that. So I've got all of my parts cleaned up and proper holes drilled in it and all polished. Now the first things were of course these little bales which go on the boom. And then the rest of this is a gooseneck assembly that attaches the boom to the mast. There's one additional part I needed to make was this little swag here. And I made this out of 1/8" bronze plate. And then I heated it up and bent it over. And then I took this bolt and I silver soldered it inside. And then I just cleaned it up and polished it. So let me show you how this gooseneck assembly goes together. So this little universal joint goes here on this mast bale. I've got a little acorn nut here to hold that on. And then these two plates go through the other side of this little universal joint. Now I haven't cut this off yet because and I've got an acorn nut that'll go on there. So one of the reasons why I wanted to make the bronze first was you can see how this is angled out here. And whatever that angle, I will need to know before I finish the mast. So that's the next order of business, is to get that wooden spar made. Well, now that I've got those fittings all made, I can now get started on making the wooden spar. And there's 3 important dimensions we need other than the length. And they're here, and they are these 3 diameters. So the first is what's right in the center of the boom, and that is 1 7/8" diameter. Now the other 2 are at the ends where it tapers down. So on the aft end it is 1 1/4 in diameter, and on the fore end it is 1 5/8 in diameter. So the first thing I need to do is to process a piece of spruce that is 1 7/8" square. Okay, so I've got it all milled out now to exactly 1 7/8. Now the next thing I need to do is to put the taper on it. So the way I'm going to do that is I'm going to draw a circle on both ends of the size that it needs to be. So that's 1 5/8 on the fore end and 1 1/4 on the aft end. So I'm going to find the center and draw a little circle on there that will allow me to start doing that taper. Now my board is really perfectly straight. If for some reason you have a piece of timber that has a little bit of a curve or a crown in it, this is when you can adjust that where you're going to taper it at. So you can use that crown as part of it and then just take the material off on the opposite side of the crown. But mine's perfectly straight, so I'm just going to find the center and draw a circle of those two diameters on both ends. Well, I've got both ends marked respectfully, the fore and aft, and I also have found the center line here. What I'm going to do is I'm going to start by coming out a little bit and cutting with my power plane, and then I'm going to move in and take another cut and slowly move out to the end until I meet that little circle. By doing that, then I'm going to get a nice curve, as opposed to if I just started here and just started power planing down, then I'd end up with sort of a flat looking spar. So what we want is a very gentle taper down to both of those ends. Now some people have asked me in past times when I was making spar, why are they tapered? And they're tapered solely for an aesthetic reason. It's the same reason the Egyptians tapered columns instead of making them perfectly straight. It just would look clumsy if they weren't tapered. So anyway, I'll get started. So when I did the fore end, where I was only taking 1/8 of an inch off all the way around, it was really easy to get a nice fair arc on there. Now when I started doing it on the aft end, where I needed to take nearly 3/8 of an inch off of each side, it was a little more difficult to keep a really nice fair line. So what I've done is I've put a batten on here to get a nice fair curve. So what I'm going to do is mark that out so that I have a guideline to sort of go to as I'm planing it down. Well, now that I've got the taper put on the spar, now what I need to do is turn a square into an octagon. And I'm going to do that with the spar maker's gauge. So as I had just mentioned, what we want to do is turn this square into an octagon. So I've put 45-degree marks on there. So what we need to do is to have this proportion, which is a proportion of 7 to 10 to 7. Now the trick is as the taper changes, we can't just draw a straight line down there. And that's where the spar maker's gauge comes into play. So this is the spar maker's gauge, and it is set up with that same proportion of 7 to 10 to 7. And what happens then is no matter how wide your plank is, as this changes, so does that proportion stays constant no matter how wide or narrow it gets. So the way this works is to simply to put it on here, those two pins, and then draw lines. Well, I've got all of my lines drawn out on my spar, so now it's a matter of flattening this out with those two lines there. These two lines will be what I gauge by, so basically I'll flatten this off and make that another facet. And I'll do that with my power plane. In order to hold it down, I've got these little V-blocks that I've cut, and I put this on here and clamp that. And that should hold that nice and steady for me to plane that down. I powered plane down, leaving the pencil line, and then I finished up with my block plane. If I could give the younger me some advice, it would be keep your tools sharp. Well, now that I've got it 8-sided, an octagon, I need to now make it 16 sides. So I don't quite know what that's called, a 16agon. I'm sure if I knew what it was, as good as I can pronounce words, that I probably wouldn't be able to. At any rate, I'm going to knock off this high spot and do that all the way around, and eventually it's going to turn around. Well, I've got it pretty good now. There's still, you can feel some facets on there. So now what I'm going to do is go over it with the plane and just try to knock off some of the high spots. And then I'm going to sand it. And once I get it all sanded, I'm going to put some varnish on it. Well, that's the last of the 80 grit sanding, I think. So I think it's in pretty good shape. Been a long day working on this, so I think I'm going to clean up and hit it early tomorrow morning. Well, back on the boom here today, and I've got it all sanded down to about 120 grit. Now, before I get too far, I want to fit that gooseneck fitting on the fore end of the boom before I get too far along on sanding it. So that's what I'm going to do now, is to lay that out. So let me show you how I'm coming up with that. The plans show a side view of it, and if I go from the center of that universal that goes into the mast bail, and I come over to the beginning of like right here, the beginning of the spar, it is 1 inch, looks like. So, and it's rounded. So that is how I'm going to be able to locate where these boom plates need to be. So what I've done here is I've found the center line of the spar. So we're here at the fore end, and I kind of drew a circle on here, assuming the end of this will be rounded like a half of a hemisphere. So now if I take the one of the boom plates here and I set it on here like so, then and I measure out, you can see that the other universal hole that goes into the mast bail is an inch away. So I've made a little tick mark there that's how far back that plate needs to sit on there like that. Now if you'll remember, they kind of splay in like this. So what I need to do is find out what this measurement needs to be and what this measurement here needs to be, the distance we want. So at this point here, so 1 11/16. And then here, we've got 1 1/8. So if I go back out here at the end of the spar and I measure the diameter at that spot, I've got 1 3/4 inches. So I'm just about a 1/16 bigger than I need to be right here. And then what I'll need to do is taper this down to that 1 1/8 inches. So I'm going to mark off 1 1/8 inches here and then draw some lines like so that I can plane those off. So I've got that taper all cut in there, and now if I measure from the end of this to the center of that pin, we're exactly 1 inch. So what I'm going to do now is I'm going to round this end off, and then also, because I know that I have this properly, I can then go from here and go back and measure the length of the boom. The plans call for it to be 11 foot 11 inches from the center of this. So I will cut this then at 11 foot 10 inches. Well, the boom is all complete. The 2 bales I located according to the plans. The aft boom bale is 23 inches to the center from the end, and the fore boom bale is 51 inches from the center of the universal to the center of the boom bale. So now that I've got those located and the goose neck put on there, we can call this completely finished. Now there's only one major part left to make for the boat, and that is the mast. So that's what I'll be getting on to next. Now hopefully I'll have all of that done and some of the rigging so that I can take the boat out to Mystic, Connecticut at the end of June for the Wooden Boat Show. I believe the dates are the 24th through the 26th. Now if you visit me at the Wooden Boat Show and you wear one of my Art of Boat Building t-shirts, I'll have a special gift for you. So as always, thanks for watching, and remember, if you're going to make it beautiful.